Hello, students. Today we are going to look at percent composition, and we're going to do some calculations on that. So let's get started.
The percent composition of a compound is the mass percent of the elements present. Mass percent of element equals mass of element in sample divided by total mass of sample times 100. Knowing the chemical formula of a compound, the mass percent of its constituent elements can be calculated.
Note, the subscripts in a chemical formula allow us to define the atom ratio as well as the mole ratio in which the different elements are combined.
Example, in H2O, the atom ratio is 2 atoms H to 1 atom O.
Now, the two under the hydrogen is called a subscript. So in this case, we have 2 atoms of hydrogen to 1 atoms of oxygen. Now, if you don't have a number, if you don't have any subscript on the elements, it shows it's just 1. In the case of sodium sulfate, Na2SO4, here you have 2 atoms of sodium, 1 atom of sulfur, and 4 atoms of oxygen. So the atom ratio is 2 atoms of Na to 1 atom of S and to 4 atoms of oxygen. The mole ratio is 2 moles of sodium to 1 mole of sulfur, 4 moles of oxygen.
H and O in H2O. Element H. Number of moles 2. Molar mass 1.0. 2.0 grams. Element O. Number of moles 1. Molar mass 16.0. 16.0 grams.
Now remember, you are getting your molar mass from periodic table as we did in the first week of the class. There are 2 atoms of hydrogen in H2O. So you have 2 times 1 because the molar mass of, or atomic mass of hydrogen is 1.0. So when you multiply 2 by 1, you get 2. But that of oxygen, there is only 1 atom of oxygen, and the atomic mass of oxygen is 16.0. So 16 times 1 is 16. So the total mass of, or the molar mass of H2O is going to be 2 plus 16, which is 18.
Equals 18.0 grams. Mass percent of H equals 2.0 grams. 18.0 grams.
So in this case, we're looking for the mass percentage of hydrogen. So you look at hydrogen in the formula has 2 grams, and that is the molar mass of hydrogen, 2 grams. And the total mass of both hydrogen and oxygen, which is the molar mass of water, is 18 grams. That is why you have 2 over 18 multiplied by 100. So the percentage of hydrogen is going to be whatever you get from this.
Equals 11.1%. Mass percent of O.
Right, in the same way, you can find the mass percentage of oxygen by putting the mass of elements in the sample, which is 16 over total mass of 18 times 100.
Equals 16.0 grams divided by 18.0 grams times 100 equals 88.9%. Calculate the mass percent of N in C3H3N.
Okay, let me pause here and I want you to try this. Calculate the mass percentage of nitrogen in C3H3N.
Element C. Number of moles 3. Molar mass 12.0. 36.0 grams. Element H. Number of moles 3. Molar mass 1.0. 3.0 grams. Element N. Number of moles 1. Molar mass 14.0. 14.0 grams equals 53.0 grams.
Now remember that we are only looking for the mass percentage of nitrogen. So it's going to be the mass of the element we're looking for, which is nitrogen, In this case, it is 14 over the total mass, which is 53.
Mass percent of N equals 14.0 grams divided by 53.0 grams times 100. Thus, the mass percent of N in C3H3N is 26.4%.
All right, make sure you take down notes before you continue. Let's do some interactive activity.
Example: calculate the percent composition by mass of the following compounds. A. C4H6O2. Percent of carbon equals.
All right, so go ahead and solve this. Get your pen, pencil, and a calculator with your periodic table. Go ahead and find the percentage of carbon. All right, make sure you pause and complete the percentage of carbon before you move on.
Percent of hydrogen equals. Percent of oxygen equals. Percent of carbon equals. Percent of hydrogen equals.
This is the second example, C6H6.
Calculate the percentage by mass of phosphorus in P4O10.
All right, I want you to do this. Do more practice of this. Calculate the percentage by mass of phosphorus in P4O10. All right, calculate the percentage by mass of phosphorus in P4O10.
Percent of phosphorus equals.
All right, that's all about percent composition. Our next topic is going to be empirical formula. See you there. Thank you.